want to make sure. Okay. Good. Okay, so before we start the assignment, we are going to continue with our lecture, and this is going to be Unit 3 as we have the holiday during the first week, right? So we're like a week behind, but we're okay. So today we're going to talk a little bit about network technologies and how that plays into security and attacks. And, you know, without doing a lot of these attacks first, and we'll learn more about, you know, how some of these attacks are being done down the line, right? So today we're going to work on a little bit on how we would look at the vulnerabilities that are coming through on the target for certain type of network services in the lab. But just to give you some of the information about the typical common attacks that you often see in the network environment. So when we first started, I mentioned to you that like cybersecurity is 90% networking, and that is true. Without networking, we would not see a lot of these form of attacks. A lot of the protocols that we're using is been developed and improved over time, but since the 1970s, right? Before some of you are even born, or even before your parents' generation. So we have to be more comfortable with looking at the type of vulnerability we have pertaining to the type of network services, which pertains to protocol, along with your network design and so on. So when you are redesigning security solution, you often have to work with network engineers because, you know, sometimes we can't restructure the network, but we can look at what's available in our infrastructure that can be protected or be improved. So the start here, it talks about sniffing attacks. And this is just a form of capturing data. Wireshark is a common tool that you see that is open source. You can use T-Shark or other network sniffer. Basically, you are scanning all the network activity and be able to determine what's going on with that network. What can I capitalize in from an attacker standpoint? Now, from a network security person standpoint, we want to make sure that we are not vulnerable to that, right? We don't want to expose a lot of the information, but in communication, data is being transmitted regardless, okay? So you have to pick and choose the technology that you are equipping your network with and making sure that that's gonna be secure. So Wireshark, that's for network sniffing. You often see Kismet, TCDump, Kane-Enable. All of these are capable of network type of sniffing or, you know, examining the network. Kane-Enable, I think I did like a few sessions on this with my prior classes for CIS27, but you can also use that for dictionary attack and brute force password attack. It also is capable of doing Bluetooth and wireless, not as good as some of the other tools that you see from Metasploit, but it is a common tool that's been around. So Kane is popular. Now, when you're trying to download Kane, some of your security software would try to block it. So because it's, you know, its signature is known as a threat. So sometimes you can't just download it. I would recommend using these tools in a virtual environment or contained environment. And then you have EtherCap, DNS Sniff, NetStumbler. So as you name it, you would see a lot of these can be used for sniffing attacks. So these are just to name a few. You can find them online. A lot of them, you can find them as open source. And within that, you would see that another type of attack that we often see in a network environment is denial of service, right? So denial of service is a way that someone can submit a lot of attempts to request for a certain service. Often that you would see web server being the receiving end, the target. So the web server, it needs to have a four-way handshake in order to deliver the content to you when you see the web page. So that means, because it's under TCP, that means that someone can submit a lot of requests where it would get so busy that it cannot respond. And that's a quicker way. So as I was talking to one of the students earlier, I mentioned that it is a form of buffer overflow because your system needs to store things to the RAM in order to queue and fetch it for execution. So the processor needs the local memory in order to set up, right, the task that it needs to execute. So as a lot of the requests coming through, it's going to stack up all of that storage, and eventually you would run out of storage, and then the system deemed to be non-working at some point or non-responsive. So denial of service and distributed denial of service plays on the availability component of CIA, right? They want to make sure that the target is not available. And you can have denial of service not just to web server, but to your security appliance, to a lot of things. Could be an actual remote systems. Now, distributed denial of service attack is using multiple source for one target. So I can take the zombie, which could be any system that click on my link over the internet, and I would remotely control those systems to launch the attack at once, because it's all about resource capitalization, right? If I am attacking with one computer to one target, that might be number one, traceable, number two, requiring a lot of time and effort and resources, processing power and network bandwidth. Now, distributed denial of service attack, if I can capitalize on getting everybody to click my link, right? Social engineering. Once they click it, I remotely control their system and it's launching from everywhere. So when you're visiting one of those websites where it maps all of the attack, you would see denial of service attack being shown as a bunch of arrows coming through to one target. And I will open that up in a little bit to show you. Okay. So let's go through and answer some questions so we know, and hopefully you can see the red. So number one, it says, what is a sniffing attack? This is a way to utilize network protocol analyzer, such as Wireshark, or a scanner, to determine the network traffic, protocols, and ports. But on top of that, it is useful to also find payload information. So when we say payload, that means data, and data can contain credential, right? Like login information. Data can also, if you're familiar with wireless network, right? So when I'm authenticating to a wireless network, I would be given some form of value for my initialization vector to be able to access that wireless network. And through capturing that packet, someone can obtain that information and be able to, number one, right, find way to access. Number two, sometimes if it's unencrypted information, they can obtain that sensitive data if it's unencrypted. So sniffing is a lot more harmful than it seems, right? A lot of people say, oh, I can scan a network and it's harmless. You can scan a network, it is harmless if you're not doing anything with that scan, right? But if you are scanning the network and you're using that scan for an attack purposes, then it is a criminal activity, right? So in ethical hacking, when we're doing the scan, we're studying the network environment, but we're permitted to do so, right? So if you're scanning the network and you're using that scan for a malicious intention, then it becomes illegal. So sniffing is kind of like in the gray area. So based on that list, you can just name a couple of the applications that you can use for network sniffing. You can use an application called Wireshark. You can go to wireshark.org. Ettercap, Snort been around for a long time, right? Through Snort, you would see other applications that are available through open source as well. Now, the protocols that you often see for denial of service attack is going to be your user datagram protocol, right? So my analogy for user datagram protocol compared to TCP transmission control protocol is that TCP is like a delivery service where they require your signature. The FedEx person comes and you have to sign off. So there gotta be acknowledgement in connection and validation, right? TCP requires handshake in order to transmit data. With that, TCP requires a lot more confirmation time, right? However, it's more stable, okay? Where user datagram protocol is like the FedEx delivery person just drop off the package and doesn't need any kind of validation whether you receive it or not. User datagram protocol also opens as it arrives. So this is what you see on when you're watching a video, right? It's still buffering because it's opening as it arrives. And you see that with streaming services as well. So denial of service attack capitalize on that. You often see when you're scanning your network using Wireshark, and you would see a lot of UDP packets coming through at once. Okay, because it doesn't require connection validations, handshake like TCP. They would dump, right, a lot of the requests through UDP. Now, another service that uses UDP is your DNS, right, domain name system, which allows you to convert IP to URL, and that ties to your domain, which is tied to your web server. That also uses UDP. So you would see some protocols are more vulnerable in such that some attacks use those type of protocol. However, we have to use those protocol because that's what our network is, our appliance technology is designed to use. Now, can you control it? Sure. If I want to prevent denial of service attack, there are multiple ways I can do that. I can utilize a firewall to prevent the source coming in. So let's say that I'm suspecting that a certain source from different part of the world, like China or North Korea, is attacking my server, right? I can block that IP and I can control the port. Close your doors and windows, right? But when you are blocking, when you're blacklisting, you have to keep on doing it because another source will pop up and then 5 other sources will pop up. So your firewall constantly have to be updated with its access control list, ACL. However, if you are looking at the pattern, you say, you know what? I think that it's okay to accept 10 packets that's UDP from that source. We would examine it, right, behavior-wise, but kick anything that's 15 or more out, right, or anything higher than 10. So what you can do is you can control the number of packets, the number of requests that are coming in into your network, your DMZ network, or into your private network, right, from a certain source. Now, what they do is they actually have delegation of server, and I will talk to my ethical hacking class about this, where you can set up alternate system. Whenever it exceeds a certain number of traffic, it would transfer it to an alternate system, and that system would examine it before the request would be transmitted. It will slow down the attack process. It will control the attack vector, and it does perform better, and they found it to be very effective. Cloud or no cloud environment. Okay, so that's what you see. So between TCP and UDP, right, we talked about TCP needs confirmation for delivery. So delivery assurance transmission control protocol is like that. And with transmission control protocol is like this. Let's say that you need to send a car to your friend, right, in parts. A steering wheel, some wheels, tires, transmission, engine, etc. Pedals, seats, all of those things are packed into different boxes. Okay, the way TCP works is it's going to communicate with the receiver and say, hey, are you ready to receive? And the receiver is going to say, send it my way. And so the boxes are going to arrive, right? The receiver is going to sign off that's saying that I received all the boxes and reassemble everything back together, right? Through the OSI layer, it's going to then present to you a card, okay? Now, UDP doesn't care about that, right? UDP is going to send the steering wheel at one point, and then you're going to get a wheel at one point, you're going to get a transmission at another point, and UDP is going to assemble everything depending on what it gets, okay? It doesn't need the entire set of car parts to put the car back together. So what you see is the assurance and delivery for TCP is it's going to give you more stability in communication. However, that's going to slow down compared to UDP. So if you're doing streaming service with TCP, you are going to have a lag, okay? So this is why UDP is used for a lot of like, you know, live streaming, video calling, and so on. Any questions? So some of you had networking classes, so this might be something that's review, right? CIS28 is the Network Plus class that we teach here at NVC, and it goes in depth in this area. Some of you have taken that class or will be taking that class. But these are some of the protocols that you would see that would pertain to security. There are lots more other protocols that are used, but these are mostly for network and network security. IP is mostly used for addressing. This is used to specifically identify how that system is connected to the network and or identify the system that is connected to the network. So most of the time you would see that we are still using IP version 4, which use octets or 32 bits address, that's decimal numbers. So when you look at an address that's decimal number, for example, you would see like a 10.0.2.15, which is what you see on your Kali virtual machine when you use the command IP space address, right? We've seen this before since lab 1. IP version 6 uses 128-bit addresses and it uses hexadecimal. That means that it uses numbers 0 through 9 and letters A through F, right? When you're receiving all Fs, those are broadcast address, and broadcast address is deemed to send to everybody, just like broadcast radio. Everybody can hear what that system is sending, right? Sometimes you would have multicast. That means that a group of systems can hear what one system is sending. So I can multicast to a certain segment of the network. Let's say I'm re-imaging the computers in SAS 214, right? I can set up the multicast for that, for the image. Or I can have unicast 1-to-1, right? One system sends, the other listens, and so on. So what you would see is you would see different way that we would communicate, but ultimately IP is only for addressing purposes. You would have a static address where it is permanently stored. So we would use a static address for things like shared printers, servers, right? Machines that are referred to by other machines, right, for services, okay? So we would use a static IP address. That IP address does not change. And at home, when you're signing on to your network or you're logging on to your wireless network, you're using a dynamic IP, which is given to you by your wireless router, right? Here, they use a DHCP to be able to give you a dynamic IP address. The reason why we do that is that address can be reused, right? In the case if you shut your system off for days and you don't use it, the address can be given to another system. Okay, this is for ping, so we can try this, right? We can open up our command prompt. So I meant to put in here. Okay, so you can do CMD for command prompt in your search. And then if you do a ping, right, 127.0.0.1, that simply is a loopback address, right? So ping is really good for two things, right? Number one, to troubleshoot, we can see if it's replying, that means it's connected. So we can take a look if that system is connected by the IP address. Now, when I'm using a loopback IP address, this is BusU. This is a version 4. All system can call home. That means that this is a way that I can check, the system can check itself or connect to itself and see if it's actually being communicated, right? So it basically a boomerang addresses come right back to that own system. Now, if I do if in Windows environment, to find an IP address, you simply do an IP config, right? To find an IP address. And it tells me that there's a link local. This is a version 6 address, right? If you look, this is a version 4 address. This is the subnet mask. And this is like the zip code for your computer. So it can narrow down what part of the network is that system, okay? And then it will tell you additional things. So the actual IP address is this, 10.151.101.22. And yours is different than mine because every system has to have its own unique IP address. If you have a conflict in IP address, then those systems are deemed not to be connected. Okay, so you can ping its own IP or the loopback, like here. Now we want to have 4 replies. So in Windows environment, this is considered ICMP. In Linux environment, this is also ICMP. So ICMP is used commonly for pinging. It also can be used for other things, but in Linux, when you type in ping and an IP address, it continues to do so until you tell it to stop. You can also do a ping and then a counter. I can do a ping 50, right, to that IP address, and it will send 50 packets. So when I'm looking at this 4 reply, that means that I'm sending 4 packet that requests, hey, are you there, right? Are you there? Are you there? Are you there? And if the system is there, it's response. So you see reply 1, reply 2, reply 3, and reply 4. So in Windows system, it does 4. Now, in the case where you don't have response, it will show here. That means that it will tell you the loss, the percentage. Yeah.
Is that you talking to the computer and the computer's giving you the information?
So I'm checking myself to see if I'm connected. It's not me, it's just my system checking. So if I'm pinging you, I simply type in ping and then your IP address. And my system is checking if your system is connected.
How would you know my?
I would have to ask you, right? Or in the case, if it's a public IP, right, I would have to find ways to find your public IP. So that's a good question, right? Because I asked my ethical hacking class, how can you find someone public IP address, right? Because that's part of gathering intelligence. How are you going to be able to find out what that target identity is? So there are multiple ways to be able to look at that, right? And the fastest way is to sniff, really, right? Let's say that I know that you connect to public Wi-Fi. I would follow you and I sniff you, right? And I would look at the devices that you're using, the credential that you're using. So singling out target can be, many different approach. I can use social engineering. I can call you and ask you for information, which is common. Yes.
How does Grabify do it? Have you heard of Grabify? You just like attach a photo. You upload a photo. Person clicks the photo. You get their operating system and their IP. And
yeah, so that's a form of banner grabbing. Because if you're getting an OS, that's fingerprinting. If you get when you put it up on the server, right? The server is going to report to, you know, if the program is designed to report to you who upload that photo and say, okay, I want Casey Nguyen to get that photo, right? So I would go and download it because I have to submit a request to the server. So the server is going to see my system, right? And then all of that information is then being reported to you. So that's how it does it. It grabs the banner and it does the fingerprinting
So
process.
just by calling you, then how about a photo? Or?
Yeah, so if it's simply just like you upload some information online and I go and I download it. As I download it, my system information is given to you. That's the type of service that was mentioned. Anything you download. But that's because that program is designed to do that, right? So we got to be careful too, right? On what we use. Okay, so we talked about ICMP. Now, can someone ping you a lot of times, right? The more you ping, the more the system have to respond. And this is what you see with the Smurf attack that's been done for, you know, 30, 40 years now, that someone can continue to ping and the system have to keep respond. So you can have a form of denial of service through ICMP. So some administrator, they will block ICMP. So you cannot ping. So when you ping a certain system, it would say, you know, deny, or it would refer you to a security system. You have to, there's protection there, okay? ARP is very important, address resolution protocol, right? This resolve IP version 4 IP address to the media access MAC address. So when we look back here, right? If I do IP config, I'm only gonna get the IP addresses for my system. And you notice that I have different adapter, right? This is my virtual adapter. This is my actual Ethernet adapter, and the IP addresses subsequently following that is the actual, right? And then here's the router, okay? This is the subnet. That's the zip code that we talk about, right? To narrow down where you live, you kind of have to look for the zip code, okay? Now, if we do ipconfig /all in Windows environment, it's going to give you more details, that is, right? Compared to the last one, I would get the description of my adapter, right? Still the domain I'm connected to, but it's also going to give me the physical address. This is your MAC address. So every system has a MAC address that is ingrained onto the adapter. It could be Ethernet or wireless, right? So the ARP, that protocol, its job is to associate the IP address that's given to my system or leased to my system and the MAC address. That's how the switch is, that switch level is going to narrow down and bring that traffic to my computer, because the router only gets you to the exit, right? My analogy is like driving on the freeway, right? The router is going to get you to the freeway and from the freeway to the exit, okay? The router is going to stop at the exit. The switch job is going to take you to the small street, to your neighborhood, and then your house, okay? So it needs to route to the network, and the router job is to bring it network to network, right? Freeway to exit. And then from the exit to the street is going to be your switch. So that means that we need to narrow down what segment is that computer located on, right? That's your subnet mask. And then where is that computer and the MAC address. So an attacker can spoof this, right? So impersonation is a form of faking the IP address to another system. I would only be successful if I impersonate, let's say Gabe is also on the network with me, I'm the attacker. I have to impersonate him. I can't just impersonate a random computer. I want to impersonate him because he has admin privileges, right? Does that make sense? We don't want to impersonate someone that doesn't have control, doesn't have the power to change, to modify, to, you know. So there's also like an intention when you're looking at impersonation attack and looking at the strategy on how we can move from the outside inside. And you have to think that like an attacker to protect your system against the attacker, right? So art poisoning is a form of attack that you can generate packets, right? That would give the false information to the hardware so it redirects the traffic. So any form of poisoning, you tend to see that there's redirection in that, okay? NDP, this is useful for the router, neighbor discovery protocol. This is used for IPv6 devices. So for example, I'm the router on the network. Most routers are autonomous, right? How router passes is it's gonna look around. It's like I have to pass the baton to the next person. I'm just gonna look for the next available person that's closest to me, okay? So the router is gonna advertise, and sometimes some router measure by distance, sometimes it looks at hops, like how far am I to him, right? 1 hop, 2 hops, 3 hops, 5 hops, right? So it creates a table to track like who are the neighbors. It's kind of like you're in your neighborhood and you're like, oh, that person is a house away. Like I can go to that person if I need to borrow some sugar, right? So that means that the router is going to be able to use this protocol, right, to be able to update and pass, right, or communicate. So that way you would have faster throughput. So you do have some neighbor discovering protocol being used. Then you got the RTP. This is used for voice over IP, Zoom, right? I don't think we use push talk so much anymore, right? Back in the day, push talk was really big. When you push into the device and you can talk, and then that same voicemail or voice recording is sent to another person. You can do that now over the TCP/IP network, but when you're using voice over IP, which all of us do now, right? In a business environment, you see that that's real time. But we want to go secure. So this is used encryption compared to this. Okay, that's the true difference. Okay. All right. So let's go and answer some more questions. So we talked about TCP have more delivery assurance. Question 5, it says, why is address resolution protocol important in networking? Because it is used to identify correct host or system on the network, so the packet can arrive to the correct system using MAC address, like your home address, right? Remember, it needs to look at the zip code, then find the street to your home, which is the physical address, the MAC address of that system. It's a way to convert an IP address, a network address, to a MAC address, right? Think of it like an IP address is like your neighborhood number, right? And then you would have the actual home address, the home number, right? So it's a way to associate the IP to the MAC address. Now, our system, our computer stores a table for ARP, right? And that table is used as reference for quick connection. So if I'm connected to the switch, which is part of the network, it's on that table. The next time I connect again, it's just a way for it to quickly reference. Now, someone, when they're doing art poisoning, they just need to edit that table, right? They would go and find that table information and modify it, okay? For streaming video, we talked about real-time transport protocol. One that would be more secure, that use encryption, authentication, and have data integrity. You're gonna use S, right? SRTP, secure RTP. We talked about how IPv6 devices does auto configuration of other IPv6 addresses and their neighbors. That will be your NDP. So another important thing to remember, right, outside of all the 1,000 acronyms that you know in this field, when you use it long enough, you just get used to it. It's kind of like taking a shower, brushing your teeth, right? So after, sometime you're just gonna be like, oh, FTP, I know what that is, right? But always associate protocol to port, right? And I mentioned to you, port is a logical value that's given to the system, but the way that my analogy for it is like an open window or door to that particular system for that service. So let's say that door number 20 and 21 is used for FTP, right? And door number 22 is used for SSH. Door number 53 is used for DNS, right? So we have to remember our port numbers. So when you're using regular FTP, we would use port 20 and 21. Now, when you're visiting an HTTPS, right, there are two protocols that can be used. One, secure socket layer. I think SSL version 3, most websites also use TLS, right? Basically, that uses encryption for the session that you establish on that particular secure website. So when you're logging in to your bank account, right, using the HTTPS, right, you would also have encrypted for your session, but your session ID can be jeopardized, right? It's not, there's no 100% security. It's just, we are just gonna have more protection so that way generally deterrence and also slow down the process for attack. So if we don't use secure socket layer, you would use TLS. Now, my advice, when you're using technology, look at the version, okay? If that version has flaws, upgrade to the next version. That likely that they would close out some security issues, right? These are built for specific communication system with the services. So you would see that, design always have some flaws. Source code has flaws. So we want to make sure we check the version of SSL we're using, the version of TLS we're using. If it's an outdated version, you need to upgrade because vulnerability is there. And when there's vulnerability, potentially you have attack, right? Our job is to find the vulnerability and remove it, remediate it. That's your job. Okay. Now, when you're using secure FTP, that also uses port 22, it's also the same as SSH. So when you're using SFTP, it removes anonymous login. It requires credential and communication. SSH, secure shell, requires keys for encryption. Okay. So the keys allow you to, right, encrypt and decrypt your message. So when you're using SSH, you have to generate keys. And SSH is a way that we can directly connect to another system. So let's say that I'm using my laptop as a consultant. I need to configure a security appliance like a firewall in someone's network, right? I would connect to their network and remotely. And then in order to connect directly into that security appliance, we can use SSH. And SSH is available in all OS platforms. So you can use it in Linux and Windows, right? And when you use that, it uses the common port 22 along with SFTP. So when you're scanning and you're looking at the packets, right? You're looking at the port, and if it shows port 22, likely that you're using either or. Okay, any questions? Okay, so we talked about file transfer protocol. This is used to upload and download large files. So there are public FTP server available still, right? Mozilla supports one. There, sometimes companies would support FTP. I don't recommend it, FTP server, because that just opened up an area for attack vector. So But if you want to, you can also incorporate like a file transfer type, but you can do a file storage server through authentication system, and all of that is a lot more control. Then you have trivial file transfer protocol, your TFTP. This uses UDP port 69, okay, where the other use TCP port 20 and 21. And we talked about secure shell, SSH, and SSL. Okay. So when you are accessing like simple mail transfer protocol for your, mailbox and so on, for the server, that and using LDAP, which is like Active Directory. So let's say that you're using Mail Exchange, which all of you do, right? On Outlook, and then you're authenticating with your student account. With that, your encryption, your traffic is encrypted using SSL. Okay. All right, any question? Okay, so I know it's a lot of acronyms to remember, right? What I recommend is just first, like, remember what it is and then its function. That's important, right? To pass this certification, a lot of it is to remember terminology and what it is, like definition. But ultimately, for the job is you have to know how it's applied, okay? Okay, IPsec. This is used for encrypted traffic for remote access. One of the better ones compared to other forms. So I can set up a VPN environment, and then I can encapsulate and encrypt the IP packets. This requires, the actual server features along with additional security roles for your server. And so what you see is IPsec is often used for encrypted IP traffic for connection. Like this. So the cool thing about this is the header option, right, is sent through a tunnel mode. So think of it like it is shield. So it is harder for that to be exposed. And also your payload, your data with that, okay? So it is a form of security that we can incorporate using version 4 and version 6 for private networks, virtual private network. Okay, so for email, right, SMTP stands for Simple Mail Transfer Protocol. Okay, IMAP is also another protocol, POP3. So IMAP and POP3 are for web-based email services, and then you have mine. Now, when you're doing email forensic, a lot of these things become very important because then we have to analyze like email headers, email services, the servers that are transmitting the email, and so on. So it's like how the post office that's transferring your mail from one place to another, right? All of them have record of your mail. And then also how your server is supporting your mail access, your inbox and your outbox for SMTP. You guys know what MIME is for?
No.
I'm sorry, say it again. Arcade machines, MIME? No, MIME. So this is a way that we can look at our mail in a format in a different way, right? Before this, everything in email was plain text in some sort. Like if you look at the 80s, if you ever watch like movie like The Hacker, you see that everything is very simple, right? Because the same concept is now a little bit more enhanced in the technology that we use. So it's definitely a way that we structure our mail so that way we can format it into a different way. Like you can embed pictures into the body of your email because of the technology, right? And then with POP3, the post office protocol version 3, this is what you see with like the web-based email, like your Yahoo Mail, and so on. Now, even though they say that some of this technology is old, it's still being used today, every day. Okay, so multi-purpose internet mail extension. This is a way that you can extend the format messages to support text, character sets, and attachments. So without it, you won't be able to attach picture in your mail, right? Or format things like HTML fonts and so on in your email. Like the advertisement, people won't be able to send you ads that are colorful and beautiful or embed videos in it without mine. Okay, so for IMAP, that stands for Internet Message Access Protocol, and then POP stands for Post Office Protocol. So the messages with MIME is formatted and then transmitted through these protocols. So think of it like it's a way to send email, right? I can have it exchanged through a server environment. I can have it through web-based post office environment, or I can have it with the media access protocol IMAP environment. Yes.
I always wondered, how do they make those emails? Is it HTML in the message?
It's coded.
Like I'm sending an email and I just start sending an email in HTML.
Yeah, anything that's online can be HTML source. So yeah, it is a way. So for example, if you are using like web-based, like Google, Gmail, and so on, it has a capability where you just drop a picture in and it's part of the body, right? Mine does that, but what that does is it converts your image and it puts it into the body. So if you code it in HTML, you would say / body opens and then image tag, and then, so everything is formatted. But traditionally, we were all ASCII plain text, and then eventually we format it to something prettier, right? It's really for the human, okay? All right, HTTP and HTTPS, we talked about that, port 80 and then port 443. Kerberos, keep in mind that it uses port 88 UDP. And this is for authentication protocol, mostly using Windows domain, but not just Windows. There are cases you see that in Linux or Unix as well. It needs to have the Key Distribution Center, or KDC. Along with that, it needs to have a CA, Certificate Authority. So to support Kerberos, usually you would see this for authentication server in Windows environment. That server needs to have this role along with authentication role. So you have to have Active Directory, LDAP, KDC, and CA. All of those things you have to install. Here's LDAP. This allows you to set up objects like users, groups, systems, right, in a directory, so that way the system can connect. That's how you authenticate to RCCD.
All these are software.
All these are roles in the software, features of the software, which is services. So let's think of it like this. It's like you have a business, like a server, and that business offer many services like house cleaning, junk hauling, house painting, etc., right? Same thing. The server can hold many different roles, and all those roles intertwine to give you the appropriate services like authentication, like email to your school, right?
So the server would have all this already in, or do you have to?
You have to administer it, of course. The computer doesn't do anything on its own, right? Well, arguably AI now, right? But before, you have to configure, yes. Okay. So let me bring this down in case we're still recording 12. Okay, so let's talk about remote desktop. So some of you might start your career as a technician, right? Most support technician is troubleshooting, fixing the problem for the client. And in Windows system, you can use remote desktop protocol for that. So you might use a product that you probably heard of as TeamViewer. It's a way to access someone's computer desktop directly, right? Windows to Windows, that is remote desktop, RDP. So with this, it also requires credential authentication, username and password. In the case where if it is protected, you will have to have some kind of key. Like if I can remote desktop to my cloud server instance, so using RDP. So in Windows, that's what we use, right? In other environment, you can directly connect using SSH, right? There are other ways. You can use like other form of services as well. So in that sense, once I connect, right, I allow the system to be connected. So if I'm the receiving end, I'm the system that, maybe Gabe is connecting to, then he has to make a request and I authorize it. So with RDP setup, you can allow it to be connected for a certain amount of time. I, for some reason, cannot use search function in Zoom today. But you can also search, right, remote desktop and on your computer to be able to initiate that. On Windows Pro or Enterprise level, you would see that you can set up like a schedule time, and then you would require credentials. So now it is secure. But it's only as secure as where that credential or who accessed that with the appropriate credential. All right, DHCP, Dynamic Host Control Protocol. This protocol is used to give out release, right? Or lease IP addresses that are dynamic on the system. DHCP snooping is a preventative measure for to prevent unauthorized DHCP server. Why don't we want DHCP server popping up all over the place? Well, if I create a rogue server and I plug myself into your network, I would start sending out fake IP addresses everywhere. It will cripple your network. Simple as that, right? So this is a way for us to be able to control, right, fake IP, DHCP server that gives out possibly non-usable IP addresses. And that's how they can also jeopardize your network, okay? So on your router at home, if you use the AC router, I know most of them have this feature. You just check the box and it would allow that. So in the case that someone is trying to give out IP addresses that look kind of real, but it's not, right? It's not usable because as a user, I'm going to come into the network, right? I'm going to try to connect to the wireless network with my device. And if I'm getting a fake IP address from the rogue DHCP server, I'm not getting internet, okay? So that's a way that they can take down part of your user network that way, is to put up a rogue DHCP server, okay? So we want to make sure we control that with snooping. So how do I do this? You would configure your switch, okay? To make sure that it is only broadcast through the trusted port. When I taught bachelor level and master level, classes, they used to write security plan and they would tell me this is what I would be doing if I need to protect this type of network, right? And they always talk about port control. I really feel like, we talked a lot about like port at the higher level, like server ports, connection port, like port 80, but we don't address enough the lower level port, like the switch port, how you connect your systems to the switch, which connects to the other switches in the network, which creates segments of your network. So switch port, right, setup is very important. computer number 5 to port number 5 on the switch, make sure that that is set up, configured. If you don't configure port to system, what will happen is someone unplug that port, plug in their computer, and that creates a problem like a rogue DHCP server. Also, they can broadcast from that port, right? Imagine all your systems are talking and here I am, plug my laptop in, and I'm just sending out messages to all the other system that's listening. And now it's gonna cripple that segment. So it's very important that we think about how we're controlling the switch, the lower level switch, right? And because I know that we do a lot of administration at the upper switches, right? In the backbone and part of the network where we control input and output for our network, but in the segment is very important as well, okay? Any question? Yes.
A layer 2 switch is working on the application, the data link? Was it data
Yes,
link?
layer 2.
And what's the difference between a layer 2 switch and a layer 3 switch?
The layer 3 switch, it's function as a router as well. Anytime that you have a layer 3, layer 4 switch, it routes.
Okay.
So that is a switch and a router. So often that you would see a higher layer switch, like a layer 4 switch, is used in an uplink or a backbone bridge switch. That means that it's before the router. So all the baby switches, like when you're sitting here, like all of these are connecting to what I call a baby switch. There are smaller switches, right? Could be 48 port, 24 ports. And then those switches connect to usually bridge switch, which is the layer 4 switch. Now, layer 4 switch can be used for voice over IP and so on. So anything above three routes, this is for frame only. So it does like, you know, segment communication only. Like it's like how we commute inside street only, right? When you get on the freeway, that's when you get the router. You need to leave town, right? That's when you get on the freeway. That's the router. The router job is to take you from one town to another town, a network to a network, okay? Now, why do I need an internal layer 4 switch? You should ask, like, why do I need to route within? Well, sometimes you need to segregate the network for security reasons, okay? When we say DMZ, it's not like it's physically located elsewhere. It's in the same closet, on the same rack, right? When you do that logically. You change the way the IP addresses is set up. You can set up a virtual local area network and segregate that. It's kind of like saying, we live in the same town, but you cannot cross that street because there's barrier, right? You just set up that logical barrier where that street is not crossed by doing IP addressing and configuring switches. Okay. Yep. All right. We talked about version 4 and version 6 IP addresses. So this went out in 2011. I remember teaching while that happened. The world just ran out of IP addresses, right? Because there's so many domains. There's so many devices, like your smart devices. Why are we still using IPv4? Well, you know, it's been the technology legacy, right? Transitioning to new, so old and new still combined. IP version 6, 128, if you're looking at the combinatorics of 2 to the power of 128, you get drastically more, right? Exponentially more in IP addresses compared to 2 to the power of 32. So that's why we went with this system. Will we run out of 128 bits? Sure, right? As we grow in population and as we use more devices, especially autonomous devices, we would then eventually run out of that version as well. They're talking about we might be running out of MAC addresses, right? There have been discussion going on with IEEE about what is the next system on how we can implement MAC addresses because there's more technology that's being produced. So vendors are given a set of registered MAC addresses like Dell, right? But Dell also contract out to like Chinese company or other company, not with tariffs now, right? We don't know yet. But you would see like Cisco, right? They have a set of MAC addresses that would be used. But they're saying that because there's so much technology that's being produced, exponentially increase in technology and its demand, eventually we'll have to find different ways to address these things. So maybe by the time some of you become professors, right, you would have a different system to teach your students. Probably to increase it, but you know, you probably have to also utilize a number of systems that would increase it as well.
That change how all the protocols are going to have to work because
Yeah. Yeah. That's why it took us so long to transition to IP version 6 with ICMP, with all of these other protocols, because it has to support both. So when you transition, you can't just transition quickly, right? It took us, what, 20 years to get all the protocols to version 6. And then we run out of version 6, then we would probably get to like, you know, 8 or something higher. All right, DNS, port 53, okay? This uses UDP. This is used for domain name resolution. So host name to IP address. So when you type host as a command in Linux, right? If your target has a name like server 1, right? That is a way to find the server information. But when you register for a domain, on the registration, you have to tie a URL to an IP or a server name to an IP. So this is a way that we associate a domain name to a public IP address. There are only 9 people in the world that hold the world registration for DNS, right? My security software told me that. I was waiting for it to scan one day and I was doing something and I looked up and I saw the little statistic on it and I was like, oh, that's kind of interesting. 9 people in the world hold the key to the world DNS, right? And I'm glad it's 9 and not 3 or 2 people because that can be dangerous, right? Imagine millions or billions of websites are in the hands of these people, right? The key. So how can you prevent DNS poisoning? And we talked about DNS poisoning. How can they do that? They can change the record of your DNS. So the A record associates the IP, the URL to the IP. If I want to redirect you, I modify the record. Where's the record? On the DNS. If it doesn't have DNS security, okay? So this is a feature that you install with your DNS. It's a configuration that you turn on, and we will do that later, right, to implement DNS security. So this protects the record for IPv4, IPv6, a way that we can reverse, like if I search for an IP address, it would resolve to the URL, vice versa, right? Those are basically files on the DNS, the server itself, to translate that. Think of them as like reference file. Like back in the day, people used to say, oh, if you need to find a book, go to a library and look up a reference file, right? And that's how you find. So the system has a file that is a reference file to associate name to IP and IP to name. So when you install the DNS, it goes through that process. When you configure it, you check this option. It's going to protect the records on how that's being response. Now, if you don't do that, what happens is if they can get to the records, right, they can poison the record, they can edit it and modify it. So whenever we say poison, it's either editing the table and resave it, right, put in false information or their own information for their server. So that means that you can, when it validates the response, it's going to redirect it to their server instead of our own server. Okay, so you see that with poisoning. Let me see. After the IP address, keep going right here. So starting at 6 and on. All here are the records. Your A for version 4, quadruple A. So I just remember these things because I used to teach a lot of Microsoft classes. CNAME, so Microsoft Exchange. So these are the records. Now you can, you can set up specific records, right, for the functionality of your server. So if I have a DNS that would support mail exchange, like what you see with like Outlook or Gmail and so on, right? You would have an MX record. Yeah, so these can be jeopardized and they're stored on your server. So here's some picture on how that is. So they can put in a fake IP. Now with DNSSEC, it gives you an RRIG, which is a record signature for the resource, which gives you data integrity. So ultimately it validates that these are the real records, not the poison records. Okay. And I think, did I show you guys how to do NS lookup yet? So if you do NS lookup, right, and it will tell you your domain, your DNS. And when it goes into this little caret here, you have to exit out of it. So you can type exit, okay, to go back to your pop-up. Yeah. And in Linux, you use dig in place of NS lookup. So this is important. Whenever that you troubleshoot, right? You turn on your computer, you open your browser, you trying to go to a website, and it tells you, it says it cannot locate the domain, right? Your domain records is not valid for some reason. You get that little error message. You first need to do is you open up your command prompt, right? You check to see if you're, you have internet connection, check your IP address, then you do NS lookup to make sure. Sometimes you have to release you have to flush, you have to do DNS flush to flush out the record, because sometimes when they update their domains, your cookies and your history still store like the old domain. So it's keep pointing to that record and it's not resolving properly. So when you have a DNS resolution issue, you need to flush the DNS. Okay, make sure we remember the ports. I know it's thousands of ports that you have to remember, but the common ports, right? The ones that we've been talking about, that's really important. So I put down some port information. So IANA, they're in charge of, how these ports are assigned. And then there's some ports. So some administrator, you would see that they would use a very high value port. That's the uncommon port that is just, a lot harder to find. But ultimately, if they scan enough, they would find it. Okay. So we talked about DNS and DNS poisoning. Okay. So in 19, I have you open up your CMD and you're going to type in NS lookup and press enter. Describe what you see as output, right? You can copy and paste it out. You can also screenshot it, but put in your own words. You can say blah, blah, blah is shown. And then when you need to go back to your pop-up for your command prompt, you type exit to return to command prompt default path. So that's how you use Windows DNS lookup tool. So that means that your system is part of the domain that is shown there, right? And it gives you the IP address of that domain.
So, just right here.
You open up command prompt, you type in NS lookup and press enter. Just follow the instruction on the number 19 and describe what you see. What kind of domain is shown and what IP address is shown. Okay. So that's how you can look up what domain you're part of, right? Okay, 20. It asks you to describe the purpose of quality of service. I've had employers that tell me, you know, sometimes I ask student this question, right? How can you implement quality of service in a network environment to have availability? Okay. So quality of service are included in technologies that are used to measure different control of traffic based on the priority on operational needs. So for example, I have a business and my business is e-commerce. I sell things online, right? So the priorities for my business for profit is going to be online purchases, correct? So that means that I need to focus in what area? My commerce server, okay? User database, websites that customer can look at inventories and products and make purchases, their shopping carts. Those are the priority. So in quality of service, that means that I gotta make sure that all the responses, everybody that visit my website have access. It's available to those people, okay? And I would focus my bandwidth directly in that area, in the priority area. Now, this is different than somebody that you would see in another type of business. So let's say that I'm in the business for banking, like physical banking, where you come in and you do a withdrawal and all of that, like brick and mortar, right? Then you would look at the priority. So the way that you identify this is you map out the processes for the business. Identify the most important processes for that business and the associated system. And you do this for security, right? We have to really look at if that system is down, how much time do we recover and how much money is lost in that time, right? So your availability, your downtime tolerance, and how soon, because if you're more than, you know, like let's say 8 hours downtime, then you're pretty much gonna lose a lot more money. So imagine you go to Costco, it's like a $200 store, right? Every shopping cart comes out $200. So if you have 100 shopping carts on a Sunday, and if they're down for that hour, that's what, $2,000 for the transaction that they lost. So their priority would be transactional system, right? The sales terminal, even the self checkout and everything else. That's comparing to web e-commerce, where the web servers become more important because the brick and mortar store, their technology needs to be shifted. So what you need is you need to make sure you configure your network appliances to be able to provide more bandwidth for a specific area of the network that needs the priority. Okay. All right. Any questions? Okay. So earlier we talked about broadcast storm at the switch level, right? So broadcast storm is just like sending out signal to everybody, and eventually that creates flooding or looping. Okay. Because everyone is listening, but there's no way to respond. And you can do that continuously, where system has to listen, but you won't be able to have any kind of receipt. So what you see is in the switching technology and the appliances that you see with the network, we have a protocol called spanning tree protocol. This allows us to prevent storming or flooding in communication of your network appliances. The newer technology that you see with the appliances is your RSTP. And this can be configured, right? So out of the box, your switch might have this. If you don't configure this, you might have a flood here and there, right? That creates downtime for your network or that particular segment. Then we can't resolve the quality of service like what we talked about up here. So if your appliance is capable of doing this, You just need to make sure that you configure your STP or your RSTP. So that way it would block like the broadcast storm that we talked about at the switch level. Okay. Now, not all switches will have, so you have to take a look at the technology. You can have Cisco devices that's like one model up and it doesn't support certain things. So, that's why sometimes Cisco certification is difficult to tackle outside of the simulated environment. So what I tell the students is I said, packet tracer and a lot of these things are really good for practice, but you have to understand that there's different models that you're going to see in the real environment that uses different commands, different version of iOS. And then it might not have all the services. So you have to look at like alternative ways to configure. So if you want to get good at network security and networking, if you can find used appliances, there are some online for very cheap. Even some I've seen like switches, router, security appliance like ASA for $50. We do have appliances here as well. Practice. You can buy it and just like be able to set up a connection and log in. Okay. All right. Let's touch on firewall next. So here, right, we talked about unicast, broadcast, and then there's a flood attack. So I want to emphasize this a little bit before we move forward. So when you have a MAC flood attack, okay, it's just overloading the switch with different MAC addresses that would be associated with the physical port. Earlier, I mentioned that, bless you, the switch, you need to associate like what that port to a certain address, right? Well, if there's a MAC flood, it's just going to update the switch table with different MAC addresses for the port, confuse the switch, and then you would not have the appropriate connection. So that switch is going to then start blinking and then it's not working. So some switch would have flood guard capability, but not all would. So you just got to make sure that you monitor your switch and then configure your switches. Okay. And then your STP, as I mentioned right here. So ultimately, it's gonna, if your loops is detected, it's gonna shut down that port. So that way it doesn't keep going, right? And then your routers, make sure that we control IP address port protocol, the traffic. Like I mentioned before, implicit deny, you have to keep denying always, okay? So it's probably better to create a feasible allow list, and anything else outside of it, it's going to deny. That's part of anti-spoof. Okay. When you're connecting two of the same devices, that's considered a bridge. So in this case, let's say at home you have a wireless router, and then you might have like two hubs or two switches. You can bridge them together. And then in that, you can have like an office here, and then maybe for all the other smart devices home use, right? The challenge with the IoT, like your TV and surveillance camera, they're, the security, it's all rely on the firmware. So make sure that you update your smart devices regularly, right? Like your smart TV, go through the software updates and things like that. Make sure you have authentication, make sure your PIN is lengthy enough, the whole process. If someone can get into, they can hack the printer and listen in through the wireless printer. A lot of ways to get into the network, I'm sure you've seen. Okay, firewall. These are some of the basics in the firewall. There's host-based firewall. That's like your application that you installed on the computer. Windows firewall is a host-based firewall. Okay. There's application-based firewall, the software, like your security software that monitors and filter and log traffic. That's application-based. Your network-based firewall, that's usually controlling what's coming in and out. Those are also called border or edge firewall. What's leaving, what's coming in. Then you have the stateless firewall. These are the rules that can be implemented. Permissions, protocol, where it's coming from, where it's going to, and the port that. Okay, so this is the stateless rules. Now, if you do deny all, that's going to be implicit deny. It's going to block any traffic that wasn't allowed on the access control list. So it's going to use the control list, right? That's going to be the reference to determine if it is deny all. Okay, how is stateless different than stateful firewall? Stateful inspect traffic, where stateless only inspect packets, or like where it's coming from, where it's going to, right? So it inspects the session and sometimes even data. So the common issue with stateful firewall is misconfiguration. This is how they bypass. So the hardest part probably entering the network for an attacker is to get through the firewall. And to get through the firewall, I have to be part of the internal network to remote in, right? And authenticate. So I have to have the appropriate credential. I have to come from a certain legitimate source, okay? And I have to use an appropriate port. So this is why threat intelligence, right, and vulnerability gathering assessment is critical for your network. Because someone can study your network, they would say, oh, so-and-so used this IP address logging into the remote system at this time and with this credential and get through. Okay. Then you got web application firewall, your WAF, and there's tons of open source Linux environment. I do this for many of my classes to implement WAF. So this is a way that we can place some kind of protective measure for our web server, between our web server and our client. It can be appliance specific or software. And so, but the recommendation is you should use this in addition to network-based firewall, okay? So the joke is that whenever you talk to a security person, they always want to buy a box and configure that box, and that's true. Because if you rely on software on that particular system, if that system is crippled, the software is crippled. So you have to have multiple appliances to handle that, right? You have to have internal protection and, you know, at the edge or outside protection. So network-based firewall, the actual appliance is ideal because it's its own computer, and you don't have to rely on the server that's running the application, because if that server is crippled, your application is done. So you should not have a single point failure. And then your next generation firewall, this tends to be, you know, if you're applying for a security specialist job, right, and you set them entry level, they might ask you a question about firewall. I would, okay? So for next generation firewall, these are going to be a little bit more advanced. You got the first generation, second generation, and next generation. So the first generation is packet filtering. So it inspects the packet using stateless rule. We talked about that earlier. The second generation, it looks at the session rate, which uses stateful. So this is stateless and stateful. Then your next generation firewall, your FW, I'm sorry, that would be deep packet inspection, and it's going to do application level inspection. So this is a lot more advanced and intuitive. This is preferred in the current day. You can also do content filtering and URL filtering. So content filtering is like this. You don't want data leak, then you can content filter based on social security number, right? Health identity, like X-ray, it's gonna block it. URL filtering, you can block and filter or whitelist. We can add the URL that we accept, and it's gonna follow that. Anything else, it's not gonna allow. You can also specify the type of application protocols. Like for example, you already saw, right? We do mail, so we're gonna allow mail protocols. but we don't allow, like, let's say streaming in our sensitive environment, then we can block application protocols that way. Okay. And so you can do a screen subnet. Okay. So here is the internet, which is the public IP. There's your edge firewall. So when you look at this diagram, you're like, oh, wow, is it like a physical space? No, everything is in one room and one rack, right? Logically, we place it. So internet coming in, that line is connected to the firewall appliance. That firewall appliance is then connected to your router. Then your router is then connecting to your big switch. And I would have the bridge switch. One switch is going to be for these servers. Okay. This is for your, what's this right here? This is your screen, right? Your internet facing, so that's your DMZ. Okay. Then these are for your servers. So that could be multiple systems with the role. So I would have a mail server, a web server, and a certificate authority server. This is going to be used for the web server for certificate issues. Then, right with that, in the other switch, now I'm going to, or before the other switch, I'm going to connect the firewall. And then with that, underneath that, a switch. And then underneath that switch, in that switch, I'm going to connect the other servers. So that means that when it's passing through, coming in from my internet service provider, it's going to hit the firewall, right? Get to pass through that, getting to the router, pass it down to the switch. These are the servers, so that's going to handle any kind of public request. If I'm logging into the internal network, it's going to get into the firewall, pass through the router, kick it over to the second bridge, and go to the second firewall. Then I can access the internal database server. Okay. So this diagram lacks like the router and the switch appliance and things like that. But when you look at this, yes, it's good with the two firewall, but you need to have like intrusion detection system on the inside here. And there are other things that we can add to improve the security for this part. Any question? Okay, so for 22, it asks you the firewall rules that are implemented for ACL to identify and allow and block traffic. We're going to use stateless. Let me move 22 down. Okay, sorry. All together. I know this assignment is kind of long, so we'll get to 7 and we'll take a break. And then the function for the next generation firewall, we know that it does deep packet inspection. And it also does application level inspection. And with that, right, we would have more enhanced protective measure for next generation compared to the first or the second generation firewall, stateless or stateful. When you are setting up a demilitarized zone, which is an internet facing area of your network, right? You probably heard about DMZ, often referred to, like if you ever visit, like, before North Korea, there's the DMZ where tourists can visit. But DMZ in the network environment is where we would have public facing system. There's some protective measure in that, but that's before our private network. So it is a layer of protection for internet facing server while allowing connection, like your web server, right? And maybe some email server. Okay, next. What we have is the next question. It asks you the primary difference between static and dynamic NAT. So NAT, N-A-T stands for Network Address Translation. What this does is it can take a private address, an address that's inside your network, and translate it to a public address. So we know that at home, you might have, let's say, 7 systems, right? Maybe a couple laptops, tablets, maybe a smartphone or 2, and smart TV. But everything connects to the wireless router. Your router does network address translation because your internet service provider only gives you one public IP address. So it takes all of your private address from your tablet or your laptop or your smart TV, and it associates that with that public IP address. So everybody uses that same public address. It's like how in the home, you might have many people living there, but everybody that reports to the city is one address, one home address. That's your public address, right? So this particular protocol, its job is to convert a single IP address to a single public IP address, or in a dynamic way, it would do a multiple public IP addresses to, or I'm sorry, uses multiple public IP addresses in one-to-many mapping. Okay, so at home, you would have multiple private IP address to one public IP, okay? Many private to one public, okay? And in a dynamic way, it might be able to use multiple in the range, okay, to that one. And that is important because without it, we cannot use our virtual machine. We cannot use our internet at home, okay? So on your virtual machine, it's default to NAT. So what it does is it associates your IP address 10.0.2.15 for your Kali Linux virtual machine to the host IP, which is part of the private network, and then to the public IP, right? So NAT is functioning at multiple levels, from virtual machine to the host machine to the public IP. So anything before the router, private IP address, anything after the router, public IP address. Know the difference, okay? They are not the same address. Okay, the purpose of non-transparent proxy, let's talk a little bit about the proxy. So proxy can be used to intercept. Proxy can be used to regulate traffic, like let's say in a high school and I don't want the kids to visit certain website, I can set up a proxy to regulate the URLs that they visit. They're like traffic police, you know, like how when you have a detour and that traffic police said that you cannot go straight, you can only make a right, right? The proxy can do that. It can regulate all this type of traffic, go this way, right? What about all the 18-wheeler trucks? They can go left. All the other cars go right. So proxy can be functioning in a lot of ways for security. So let me get down to that section so you can see. And then I'll come back to some of these things with VLAN and air gap. So you can set up proxy with server systems, okay? Or you can have it with appliances. So a transparent proxy, it accepts and forwards requests without modifying them, okay? So it's kind of like you still have the same traffic police, but it will just let you go to the way that you normally go. So it is a way to cache. So we can do this for monitoring purposes. So we can do a transparent proxy. A non-transparent proxy, it accepts, forward, modifies based on rules. Remember what I said about the high school? They do a non-transparent proxy. That means that we can regulate the traffic based on what's allowed and what's not allowed. Now, a lot of my security students are highly interested in reverse proxy, right? When you're doing burp suite and then when you're setting up like when you're using certain tools. So it does the access request from the internet from a single web server or a single point. It allows that web servers to be located in the private network behind a second firewall. So you can set it up this way. So the reverse proxy is here, right? So you have an edge firewall. You would set it up before your internal firewall here. Okay. And often that you would see this, it falls right into the web server area perfectly. And so this is a way that we can also load balance. Remember, we talked about quality of service. We would load balance through the reverse proxy, but we can also intercept and monitor through the reverse proxy. So this is a good way for the security side, but also the attacker, they can also set up a reverse proxy. Okay. So you have to really look at like what's popping up on your network, right? If they're already in behind the firewall, then they can start placing things there. So we want to make sure that we check for that. So coming back here. Okay. So the non-trans proxy, we know that it would accept forwards and modify requests based on rules and filtering. Like, I don't want certain websites to be visited, or, you know, I don't want certain traffic to be submitted. So it would be the first to accept and sends it forward. So can you set up a proxy to regulate denial of service attacker? Yes, you can. There are other ways to be able to regulate that, right? But if they cripple your proxy, then it's going to slow down every other connection as well. So we would then see that, yes.
What kind of proxies are being used to anonymize itself?
Anonymize for what? Like, like to mask yourself?
Yeah.
A non-transparent proxy or reverse proxy. I would do a reverse proxy. That what? Yeah. Yeah. In a regular network environment, you can have hundreds of proxies, right? So in an enterprise level, you would see that they would use proxy to load balance. So they would say these 5 proxy handle this type of traffic. But when you set up a reverse proxy, you're kind of in between, and you can go about doing other things that might not be visible, you know. But there are other ways to do that stealthily. You don't have to, because if you can bypass through the firewall, but you're before the internal firewall, you actually want to be behind the other firewall. So the reverse proxy kind of exists in between, you know. So if you know, if you spoof your MAC and IP addresses and find a port to get in, then you get in. And then normally, a lot of times, you know, if you launch attack externally, you're gonna get blocked. So a lot of the time they launch the attack within. So once you get in, then the attack's. Okay, so we can do this on our computer, right? You don't have to download this, but if you do this at home, you can download it. You can search for Wireshark. I just want you to take a screenshot of your scan. I, for some reason, cannot. Let me see if I can run it from the command. Oh, no. Hold on. Let me see if it's like the Zoom thing, which is my toolbar.
Wireshark is it's just looking at traffic all the time, right? I mean,
it's pack, yeah, until you stop it.
when would I want to use Wireshark in concert with something else? I've heard like using Nmap with Wireshark.
Oh, you can use Nmap with a lot of things, with Nicto, with Nmap is great. it works with a lot of other tools. So the Wireshark is usually for sniffing attack and its initial. You can use Wireshark with other tools, but it's for gathering intelligence. It's pre-attack. So what you see is you would be able to analyze packets and things like that. So if you can understand the network in a very specific way, you just need to capture it for a certain period of time. You would see what appliances are talking, right? A wireless network, a regular wired network. So once you have that information, you would be able to determine, like, you can map out like what's on the network. Okay, so open up your Wireshark. I'm trying to, let me see.
So we don't have to download it?
No, it's already installed on your computer. Let me see. And then you would run. So for this example, we just need to, or this exercise, just take, so when you open up your Wireshark, you just click the fin to start, right? Wait a couple minutes and you can stop. So basically you stop the capture. In the real world, you would save that file and you can always go back to it. So in my forensic class, I use a network capture and that's how we can find malware. So in the case, if you have ransomware that's coming through and if you're monitoring, you take that capture and you pull it down, you can actually get the file. And you would see where that's coming from. So forensic team, they would be able to identify like who sends it, where that's coming from, because if it comes into one system, it will be able to spread. So physically, you have to detach, like unplug the cable from that computer. But that's after the fact, right? So that way you can contain it and then you can analyze it. So when you take that capture, you can always go back. So in the case, if you have a live attack, go back to that network capture and you would be able to see the source, the packets that coming in, okay? So expand the internet protocol. So you're gonna click the arrow down and you would find the information, the destination system. Let me see if I can get on.
So I click the link and I get the page where it says download.
No, you need to open up Wireshark on your computer. Search on your Windows search bar on the bottom and type Wireshark and the application is already installed for you. Let me see if I can run it on my laptop.
Progress.
Wireshark Windows.
Just Wireshark. Let me run updates real quick. Okay, so when you start the Wireshark, let me mute on this. I don't know why it's not. Okay, so we will share showing the Wireshark. Let me mute. So that way we don't hear both. Okay, so you're gonna select your network adapter that is gonna show the wiggly sign, right? I'm using Wi-Fi only, so you will have an Ethernet, like, it would say Ethernet. But we don't want to select the virtual box or the virtual adapter. Okay, so we're gonna select the actual adapter that we have on the computer and click the blue pin. And it's gonna capture everything on the network, and we just need to let it run for maybe a couple minutes. And some of you have done this for my other classes, so you're familiar. And you would see there's like UDP, traffic, source, destination, and then it would show you the details, right? They are color coded, so you would have like some type of traffic in a certain color. Okay, so when I need to stop, I can click the red button, and you would take a screenshot at this point. Okay. Then we're going to select, so it says click the first packet. So let's say that I can jump to the first packet. And I'm going to expand this packet. So when you see the bracket on the outside like this, so that means that it's part of a conversation in the larger conversation of the network system. And then I'm going to expand the internet protocol. And here, what you would have is you would have a source and a destination. So in the IP header, you're going to see where it's going to and where it's coming from. And then since mine, it's showing my first packet is a Cisco device, you see how the MAC address for the appliance, it would have like the vendor name and then part of the value. So you would see some appliances, they're registered like that. They would have a brand or the vendor name and then the address. So you would see that there. Okay. And then the protocol, it would tell you the type of protocol here. So you can, there's header checksum and destination address where that's going to. So under the IP part of your packet information, it will give you the destination and the destination address. And then you can also find your header lane. I think on this one, the header length is right, 25. So look at your packet, and your packet will be different because I'm on the wireless side of the house, and then also we capture at a different time as well. So in a network monitoring tool like this, it will be useful for you to go back and study, and it has like a lot of different features at the top that you can examine. Okay. And that's for a different lab. Okay. Then for the next part, for H and I, you're gonna, after you click the internet protocol, then you can shrink it back up. And then now if you don't have a TCP, you notice that mine is a UDP. It will not have a TCP, so you can leave that blank. Okay. But if let's go find a TCP one so you can see. So you can sort it by protocol by clicking the protocol tab. And you see the black ones, those are either they have error or there's miscommunication in those packets. You can also search for protocol. So on the filter right here, you would do a TCP. And if you filter it and press enter, it's going to give you the TCP suite. Now you're like, well, it's TLS is also under that suite. So sometimes you would have that. So if I pick a TLS packet, I'm still going to have transmission control protocol because it governs HTTPS, and you see that with port 443. So you have protocols that are part of the suite, right? Like TCP, or it's under the category of TCP or UDP. So when you're searching for TCP, just type it in lowercase in the filter bar and press enter. And it's going to give you the TCP ones. And then you can expand it and you can look at the transmission control information. So there's a port number. So when I see 443, I know it's HTTPS. Yeah.
So all of those jumped up hexadecimal stuff, that's the packet, right? Alright. That's like all the data being sent. And
Right here?
yeah, all that stuff.
Yeah, so your Ethernet, this is frame, this is layer 2.
Well, this over here to the far right.
Oh, yeah, so this is basically, yeah, data locations.
I can find passwords in that, can't I?
Depending on the packet. So if it's a packet that contains unencrypted password, yeah, you can go into this section and be able to dig out some information. Now in wireless segment, you might be able to find initiation vector like IV for session in wireless encrypted communication in the area here. Yeah, so it will give you the value, and then you will match that value, and it will tell you like how it was authenticated for that wireless router. For TCP, did you stop? If you search for TCP at the top, lowercase, and press enter, it won't list it as TCP specifically, but the group of TCP. I know I'm over 7 o'clock, but okay. So if you are able to find HTTP, which you likely might not be able to, but you can also find ACK. Let me see if I can find. If we search for HTTP, if we have any, then we might not have acknowledgement. Let me see if HTTPS.
Does HTTPS fall under HTTP?
Yeah, it won't filter, so let me clear. Yeah, we didn't generate any HTTP traffic. So you might not be able to find any kind of ACK number, but you can find probably sequence number. So the last part, right, is question J on that. In TCP, what happens is, let's say that if we're looking at, let me go back and look at TCP again so I can show you. So this one has acknowledgement right here. I just searched for TCP and you would see there's ACK right there, right? There's a confirmation with TCP on, when it's ready to send, right? And then when it's complete, it's going to do an ACK fin. So you would see for HTTPS, you have acknowledgement right there. And the sequence number is 4856, right? Acknowledgement number is 39847. Right? And then the window frame and the length. So, and you can expand on it and look at it, but you can see all of that in the pane there. Okay. There you go. So I just searched for TCP, and then you would find like a lot of them with the app. So whenever you deal with TCP packet, it would have acknowledgement like that. In sequence, remember what I said, right? All your car parts have to be put together in order. That sequence number is for the how it would be able to determine like which packet comes first and second. Okay. So with that, we can answer some of the question on the last page, and then we can save the work and submit. Let's take a break. It's long due for. Let's take a 10-minute break.